Hello everyone, I welcome you to this new video. Today we are going to study important circuits using this block diagram. Okay, I've made a diagram with this power IC MTK6357 CRV. So, but one thing we have to understand is that in this type of circuit, you can also use it because MTK carries two different types of charging circuit: DC to DC charging circuit and also transistor based charging circuit. Okay, so in this type, I made this video using this BQ IC. Okay, some people call it spider IC. So you can use this circuit to troubleshoot spider IC and spider charging IC, or you can also use it to troubleshoot the transistor based charging IC. It's still MediaTek. These are the lines that you will have to troubleshoot. Okay, so let me tell you the faults that you will have. If you have any of these faults, these are the lines you have to work on. Okay, these are the lines you will work on. I wanted to include the lines that if your phone is showing you charging like temperature too high or temperature too low, but there is no space, so I'm going to make a separate video on that one. Okay, if your phone is having the flowing fault, these are the lines you will work on. If your phone is showing you charging error, please unplug charger. If you are charging your phone, it will indicate charging error. Please unplug your charger. These are the lines you will work on. If any of this line is faulty, your phone will have that fault. And also, if your phone is showing wrong battery percentage, maybe your battery is fully charged, but if you put your battery in your phone, then you try to on it, it will show 1%. It will stuck on that 1%, or it will stuck on 50% without increasing. Then if you try to charge it, it won't increase, it won't decrease, it will still stuck on that 1% or 50%, and most times the phone will not on. So these are the lines you will work on. Or if you have a fault that the battery logo is blinking, if you try to on your phone, the battery logo, the empty battery logo will show, it will appear on your screen, then it will goes off. Now your phone will not on. These are the lines you will work on. And also, if you're having charging issue, these lines are also related to charging. So these are charging lines. Okay, so if your phone is not charging, you will still troubleshoot these lines, because if any of these lines is faulty, your phone will not charge. And also, if your phone is showing battery temperature too low or battery temperature too high, I've not included those lines here, usually bat on and bat ID. I've not included those lines here. These are the space I should have included those lines, but I don't want this video to be long. I want it to be very short. So if you want to know more about temperature too high, temperature too low, let me know. Okay, or you can join our online training. We have it there. Okay, you study how the circuit works. So without wasting time, let's dive in. Okay, if you look over here, we have here charging port. This is our charging port. I've made this diagram with my own hand. This is our charging port, so that you will be able to understand how this circuit works. And I said earlier that if you don't understand how to read schematics and how to troubleshoot, not only reading schematics, because you can know how to read schematics without knowing how to troubleshoot, and you can also know how to troubleshoot without knowing the lines that are responsible for each fault. Okay, so if you want to know the lines responsible for each fault, it depends on the type of IC that the phone model that the phone is using. Okay, you can join our online training because we discuss everything there. So this is our charging port, this is our V-bus line, then this is our OVP, this is our DC to DC converter, this is our battery connector, and then this is our power IC. Okay, so now in MTK we have two types of charging IC. We have the transistor-based charging IC and the BQ charging IC, that is DC to DC converter. Some people call it spider charging IC. So if you are working on transistor-based charging IC, single transistor or double transistor, these are the lines. You still find these lines there. So these are the lines you still work on. And if you are working on BQ IC, charging IC, your DC to DC converter, then these are the lines you will still work on. Okay, so either way, even if you are working with this type of charging IC, transistor based or BQ charging IC on MediaTek, on MTK chipset, these are the lines you work on. One thing I will tell you is that the way this MTK 6357 lines works is far different from the way Qualcomm IC work, and the way Qualcomm IC work is different from the way SPD, that is Spectrum, works. So if you really want to know how SPD chipset works regarding the faults that I mentioned earlier, your unplug charger, temperature too high, temperature too low, they have the similar faults but different lines. Okay, for example, MediaTek, it has different lines that are responsible for that kind of fault. Now Qualcomm have different lines, not this line, different lines that are responsible for that same fault. Also Spectrum have different lines that are responsible for that same fault. So you have to study the IC itself. Don't just study the board, don't just study the phone model, study the IC, so that even though there is no schematics diagram, you know how to troubleshoot it. Alright, so these are our charging ports. We all know that our charging ports give out 5 volts into our OVP. This IC is our OVP IC, responsible for protecting excessive voltage from crossing to our charging IC, because charging IC should carry 5 volts. So if 7 volts or more than 5 volts travels from this V bus, this OVP will block it. Okay, it won't allow it to pass. So now we come here. Now after our OVP IC, we have our V bus line, still 5 volts. We have, remember, we have some components here. We have some capacitors. Sometimes diode is being fixed here as a protective component, so it will travel to this line. So we have our V bus line, 5 volts. Okay, this 5 volt will enter our charging IC, usually pin number 24 and pin number 1. This is our BQ IC. Okay, now before this 5 volt enters this charging IC, there's a line that comes out here, still our V bus line, 5 volts. So when this line comes, there's another line that comes here. It's called VCDT. This is our VCDT line. It enters our power IC. So if you check our power IC in our charging section, you will see this line, VCDT line. So, and now what you notice here is that there's a divided circuit here. So now this is our R1 and this is our R2. I made a video on how you understand how divided circuit works. So if you don't know how divided circuit works, go to our channel and then you check out, you will see this video how divided circuit works. Then you watch out, then you understand how this divided circuit works. I'm not going to explain it again in this video. I've made a separate video on that. So this is our R1 and this is our R2, and we do know that our R2 is usually connected to ground. This is our resistor, this is our resistor, and our R1 is usually connected to the voltage, the input voltage line. So now this line carries 5 volts. Now this resistor will receive 5 volts, and then there will be a divided circuit. And now this 5 volts will step down. This divided circuit will step down that 5 volts to 0.5. After dividing, the output voltage will be 0.5. This line VCDT will receive 0.5 volts. Okay, so now if this resistor is 40 and this other one is 40, this 5 volts will to be able to enter this power IC, or the 5 volts will enter this power IC. So if 5 volts enter this power IC, you have your charging error problem. It will occur. Charging error problem will occur because this line is very, very important. So now this resistor usually carries 330k resistor. This resistor, the value is 330k. Then this other one is 39k. Okay, let me just write it. 330k. This one is 39k. In this type of power IC, this R1 will carry 330k resistor, and this other R2 will carry 39k resistor. So if you calculate it, if you calculate how this divided circuit works, if you calculate it, you get 0.5 volts. So if this line is 40, or any of this resistor is 40, or it's not dividing, or this 5 volts enters this line, you will have charging error. Okay, you have that problem, charging error. Please unplug charger. So you have to trace this line. If you have that error, trace this line, VCDT, and troubleshoot this line. So still on that VBus 5 volt, another line comes out. It connects to this resistor, and then it enters still the power IC, charging LDO. So we have charging LDO line, and this line carries 5 volts. From here, 5 volts travels. So you get 5 volts on this other side of the resistor, and then on this side you will get 2.8 volts. Okay, so this resistor will step down this 5 volts to 2.8 volts, and then it will enter this power IC. If this resistor is 40, this 5 volts might not enter this power IC, and then you have that problem, charging error. Please unplug charger. Or you will have wrong battery percentage, okay, or you have other faults that I mentioned. So you have to work on this line. So now if you check your schematic, you will see the value of this resistor. It's usually 3.3k. You have not mistaken it. Usually 3.3k. Okay, so work on this line also. Test this resistor. So I'm done with these two lines. If any of this line is 40, number one, your phone will not charge. Number two, it will be showing charging error. Please unplug charger. And then let's move to the other lines. So now this is our DC to DC converter. So now inside this charging IC, we also have a line that is called TS. Okay, this TS, thermal sense. Can call it thermal sense or temperature sense. It's called thermal sense. Let's use thermal sense. This TS stands for thermal sense. So this line is inside our charging IC, and if this line is 40, this is the line that sends the voltage that this charging IC is regulating. Okay, so now let me tell you how this line works. We have another line here, REGN, still coming from your power IC, from your charging IC. Sorry, from your charging IC. REGN line comes and is connected to a capacitor here that is connected in parallel. So this line carries 5 volts. This line carries 5 volts. So in your charging IC, this line will comes out, and then if you click this line, it will still come back to this other line, and it will enter into your charging IC. So this line comes out from your charging IC and goes back into your charging IC. But before it goes back into your charging IC, there's a divided circuit along the way. So now this line will send out 5 volts. So you will get 5 volts here, and then it will meet a divided circuit here. Now the value of this R1 and R2 are usually the same, 10k, 10k. And there's a law in divided circuit, there's a formula in divided circuit that if both R1 and R2 have the same value, that the input voltage will be divided into 2. Even though you don't have the calculator, when R1 and R2 have similar value, the input voltage will be divided by 2. If you divide it by 2, the voltage it give you will be the voltage that will enter into your DC IC. Okay, so 5 volts, you will test it, you see 5 volts, and then if this divided circuit works, this other side of the resistor you will get 2.5 volts. So this other side will give you the output voltage that will enter into this power IC. So this is the diagram: 5 volts input and then 2.5 volts output that will enter this DC to DC converter, that is a charging IC. So if any of this line is 40, if this resistor is 40 it's not giving you 10 ohms, or this resistor is 40, or it's not connected to ground, this divided circuit will not work. And then this, your phone will be having, will not be able to sense the battery. Okay, it will not be able to sense the battery. So now, if this 5 volts enters this line, enter this charging IC, your phone will still have that charging error issue. So these are the lines you will test. There are other lines, but I just want this video to be not to be too long. Okay, so this line is very important. So now the next line you will test there is, let me explain this VPH line. We all know how our charging IC works. That in our bootstrap, there's a line we call bootstrap line and switching line. So this is our switching line, and then this is our bootstrap line. So it will come out and then it will connect to a capacitor in series. It will connect to our series capacitor here, and then one side you will get 6 to 8 volts, and this side you will get 3.7 to 4.2 volts. And then a line will also connect to a coil here, and then you have your V6 line. In this MTK it is called V6, but in Qualcomm it is called VPH. Okay, so this is our V6 line, and you have 3.7 to 4.2 volts. Now a line comes out from this VPH line and goes back into your charging IC, and then it will enter and it will meet with a MOSFET, and then they will regulate the voltage, and then VBAT line will be produced, and then this line will charge your VBAT. So now, before this VBAT line, there's a line that comes out here, and now this line you will see the V6, voltage for system sense. I've not put that line here because I don't want this video to be not to be too long. If you want to learn more, join our online training. Okay, that voltage for system sense will enter straight to your power IC. So that line also is very important. If that line is faulty, your phone will have this same error, charging error, please unplug charger. See, let me tell you one thing. If you try to study this circuit, if you have the patience to watch the video to the end and repeat the video again and then learn, you don't need to go to YouTube to find solutions, because you already know the solution. When a customer brings a phone to you and then tells you this is the fault that my phone is having, your mind will tell you you already know the lines that are responsible for this kind of fault. First, you check the chipset, you check the IC that the phone is using, and then you know the line, you will go direct. See, if you have knowledge is important, try and get knowledge. If you know the lines, you just go straight to that line and then work on that line. It's not time consuming. Little time, you will repair the phone and then hand the phone back to the owner. Okay, so you have to study how this circuit works. Now we have our VBAT here line, then this is our line, goes to our battery connector. I'm going to make a video on how to use schematics to trace this line. Okay, so now another line comes out. This is our battery connector. This is the last line I will explain. This is our battery connector, VBAT and GND. Okay, now your battery connector might be different from this other one, so I'm using this other one. Okay, now in our ground line we also have a current sense resistor, CSR. This resistor, some people call it shunt resistor, some people call it sensing resistor, some people call it code resistor. So any name you want to give it, we all know that this is a sensing resistor, and this resistor is connected to our ground, and it has two lines that comes out of it before the shunt resistor and after the shunt resistor. There are two lines that comes out of it and connects back into your power IC. So the name of these lines, number one, the name of it is CSN, and this other one is CSP. CSN stands for current sense negative, and then this other one stands for current sense positive. So this line, there's no components in between. So if any of this line is open, either from the power IC, maybe your phone fell down and then you have that error. If this line is open from the power IC, your phone will not be able to sense your battery. Okay, this is sensing lines. In Qualcomm and in SPD, we also have it, but the position of these lines is different from those ICs. Okay, so in this MTK, this power IC, any MTK power IC, you will see this line not only on this specific 6357 CRV. Any MTK power IC, you will see these lines. But let me explain something. We have 4 major MTK ICs that we do use. Number one is MTK 6357. Another one is 6358. Then the other one is 6359. These are the 3 common MTK power ICs that they do use. But we also have another MTK that you won't find these lines here. These lines in that particular one is different. Okay, so I will make a separate video on that one. It is MT6360. So this power IC MT6360, they use it in our 5G phones. Okay, so the lines are different in that specific ones. So if you have 6357, 6358, 6359, you will work on these lines. Okay, but in 6360, MTK 6360, the lines are different. So I'll make a separate video on that one. Okay, so if any of this line is faulty, you have to work on this line. But how will you test this line? After troubleshooting these other lines and you know that these lines are okay, you have to lift your power IC and then check this line. After lifting your power IC, locate where these lines are connected to, then switch your meter to continuity mode, 1 probe on ground and then 1 probe on this line. If it doesn't beep, you can make a jumper, channel this line to ground, or you channel this one to ground, so your phone is going to work. Okay, so these are the lines that you will troubleshoot. So if you have any fault on that charging error, run battery percentage, these are the lines you will work on. Or you have empty battery logo, it will appear and it will goes off, your phone will not turn on. That means that the power IC is unable to sense the battery. Okay, so in that specific issue, you also troubleshoot ID, battery identification line. So I believe that you understand how this circuit works. I'm going to make a separate video on using schematics to trace this line by line. So I made a block diagram so that you understand, because in block diagram you will easily understand. Save this diagram, you can screenshot it, save it to your phone so that you'll be able to use it when you have that issue or that fault. You can be able to trace this line using this block diagram. Okay, please remember to share this video. Share this video, please. Like this video, comment, and also join our online training class. You will learn more. All right, have a nice day. Thank you for watching.